diesem Beitrag.
Here, I present the holistic approach used at Fraunhofer IWM to numerically simulate the entire sequence, beginning with the powder and ending at the mechanical properties. For this purpose, we apply a combination of simulation tools, each of which has been identified as best suited to model their respective physical effects. The powder spreading is simulated using the Discrete Element Method that can model all types of powder flow behavior. The result of this simulation is the powder distribution in the build chamber. A ray tracing algorithm describes reflection and refraction of the laser beam. Once the powder particles liquefy, we use Smoothed Particle Hydrodynamics to model the melt pool dynamics. This method can represent a great variety of physical phenomena. For instance, how hot does it get when the particles melt? And how do the powder particles fuse together? One important result of this simulation is the shape of the melt pool and the temperature history. Both pieces of information are required for the subsequent simulation step, the evolution of the microstructure. In order to predict the formation of the metallic microstructure, we apply a method called cellular automaton. For this simulation, we use the local temperature to compute the growth kinetics of the microstructure grains. The results of this simulation display the shape, size, and orientation of the grains, which constitute the microstructure of the produced part. Mechanical properties. This means, how does a material behave when it experiences external loads? We simulate these properties with the help of the finite element method. Here, we make use of the microstructure from the previous simulation step and apply a selection of external loading conditions. Then, we compute the response of the material and derive the mechanical properties of interest, such as the Young's modulus and the yield stress. The holistic approach in which we derive process structure property relationships using multiple simulation methods is a unique aspect of the service provided by Fraunhofer IWM.
Methoden abdecken können.